Hello everyone. Today we are going to show you a setup for installing Windows 10 from an SMB share on an IP storage area network, or iPSAN, to a client PC. To accomplish this, we will be using an Ubuntu server as a DHCP, TFTP, and iPXE server, along with being our gateway, a FreeNAS server for our iPSAN, a standard Ubuntu installation to create the iPXE firmware, a Windows 10 PC used to create both Windows 10 and Windows 10 PE installation packages, and finally a client PC on which to install Windows 10. A simplified version of how the system works is as shown in the diagram. A client PC is configured to network boot, then connected to the network and powered on. The client PC boots into the pre-boot execution environment, or PXE, then contacts the DHCP server for an IP address. The DHCP server also hands out the location of the iPXE file, which when loaded gives us much more features to work with than PXE, and also the location of the iPXE boot menu. Once booted into the iPXE menu and the Install Windows 10 option is selected, the client PC receives the information on where to find Windows PE to boot into and the location of the scripts to run, which start the Windows 10 installation from the Windows PE environment. ISC-DHCP-server is the DHCP server for our system and will be handing out IP addresses as well as the locations to download iPXE and Windows PE from our TFTP server. This is our DHCP configuration, which will vary depending on your network configuration. Our sample is a very basic version of what you will need for creating a DHCP server. The specific settings on the DHCP server that we want to focus on in this video are the options that relate to iPXE functionality. Edit the ISC-DHCP-server configuration file located at etc dhcp dhcpd.conf to make the necessary changes to run iPXE. The first line we will need to add is if exist user-class and option user-class equals iPXE to detect if the client is already running iPXE. This prevents a boot loop where iPXE will try to contact the DHCP server again each time it initializes. Under the if exists line, we will also need to add file name iPXE/menu.iPXE as well as file name iPXE/undeonly.kpxe in the else line as shown here in the configuration. These commands are used to tell the PXE client where to find the iPXE menu to get its boot configuration, or, if that fails, where to find the universal driver iPXE firmware undeonly.kpxe. We will explain how to obtain these files later on. In the TFTP directory, var lib tftp boot in our case, we will need to create two subdirectories named WinPE and iPXE. Use the mkdir iPXE && mkdir WinPE command to create these directories. Use the chmod -R755 command on each of the directories to give us read, write, and execute permissions in the directories, and giving everyone else only read and execute permissions to the files inside. We will need to download WimBoot from the official iPXE website, which is linked in the description below this video, and we will build the undeonly.kpxe from the source code. Universal Network Device Interface, UNDI, is an API used by the PXE protocol, and undeonly.kpxe is the iPXE firmware we serve to iPXE clients to give us additional features over our PXE. To build iPXE, you first need the following packages installed. Afterward, we run the git clone command to check out a copy of the code, and the next two commands to build the firmware image. Now we can exit and download WimBoot from the iPXE website. Finally, we will extract the WinBoot zip file we downloaded and transfer the WinBoot file from it to our TFTP server in the WinPE folder we created earlier. Afterward, we will also transfer the undyonly.kpxe file we created into the iPXE folder. To generate the iPXE menu, create a menu.ipxe plain text document in the iPXE TFTP subdirectory. The menu should contain the following commands as shown on the screen. This configures the client after selecting Install Windows 10 to use WinBoot to load Windows PE from our TFTP server, then initialize the Windows 10 install, whose files are stored on the SMB share. We will go more into detail on WinBoot and the other TFTP files later. You can find the pre-made iPXE menu example for booting from an SMB share in the description below this video. The first step to configure the iPSAN FreeNAS is to navigate to Services and turn on SMB and set it to start automatically. Next, create a storage pool for file storage. Create the storage pool under the Storage option and then Pools. We recommend at least 20 gigabytes of storage for the pool. Give the storage pool a descriptive name, such as WinPool. After creating the storage pool, add a data set to the pool. Do this by clicking on the ellipse, the three dots next to the pool, and select Add Dataset. Give the dataset a descriptive name, such as Win10, and set the share type to Windows. We will keep the case sensitivity set to insensitive for this example, since it's a Windows install. Once the options are correct, hit Save. After the creation of the dataset, create a user account for access to the SMB share. Navigate to Accounts, Users, Add. Give the full name of the account a descriptive name, like WinPE, and a descriptive username, like WinPE, and set the password to a strong, memorable password. Select the Microsoft account checkmark and hit Save. Next, we will edit the storage pool permissions by navigating back to Storage, Pools, expand the pool by clicking the down arrow, click the ellipse next to the dataset name, and select Edit Permissions. We want to set ACL type to Windows, Apply User is enabled, the user is WinPE, Apply Group is enabled, the group is WinPE, and then hit Save. Now go to Sharing, Windows SMB Shares, and click Add. Click the folder icon to select the path and navigate to \MNT, WinPool, Win10, then left-click Win10 to configure the path to MNT WinPool Win10 and click Save. Your FreeNAS server is now set up for the next step of the process, generating Windows 10 PE image using a Windows 10 PC. Download and install both the Windows 10 Assessment and Deployment Kit ADK and the Windows 10 PE ADK add-on. Both of these installs can be downloaded directly from Microsoft. You can find a link in the description below this video. Once the ADK and ADK add-on are installed, generate the Windows 10 PE installation files. In this example, we will show you how to generate both 32 and 64-bit versions of the Windows PE installation files. Browse to and right-click Deployment and Imaging Tools Environment and select Run as Administrator. Create a working folder by issuing the command mkdir c:\temp winpe. Extract the 32-bit Windows PE files to a subdirectory with the command copy PE x86 c:\temp winpe x86. Then extract the 64-bit Windows PE files to a different directory with the command copy AMD64 c:\temp winpe AMD64. Once these files have been extracted, transfer them to the Ubuntu server. To transfer the files we just generated to our Ubuntu server, use any FTP or SCP software you like. We will use WinSCP to connect to the Ubuntu server at 192.168.10.2 using SCP port 22, which is secure FTP, and our Ubuntu server user login credentials. Simply drag and drop our x86 and AMD64 WinPE folders from the Windows 10 PC into the WinPE subdirectory in our TFTP directory. Create an install.bat plaintext file and a winpeshl.ini plaintext file in the tftp/winpe directory on the Ubuntu server. These files will tell our WinPE client PC to automatically log in to our SMB share, start Windows PE, then start the Windows 10 installation. Install.bat contains the lines wp init, then net use z:192.168.10.2/w10 user:winpe followed by your FreeNAS user password. Then change to that directory by typing z: and then run setup.exe. In the winpeshl.ini file, we only need one line, install.bat, which is in quotation marks. Lastly, log into the SMB share from the Windows 10 PC and copy a Windows 10 installation ISO file onto the SMB share. Navigate to this PC, then at the top select Map a Network Drive, and then type the SMB share IP and directory, which is 192.168.10.2/win10 in this case. Once logged in, drag and drop a win10.iso into the SMB share using File Explorer. This completes the setup and configuration. To start the testing phase, we need a test machine without an operating system. Make sure that network booting has priority over hard drive booting on the machine. Boot the PC and it will get an IP address from the DHCP server we set up in the beginning of this video. Once the IP address is negotiated, standard PXE will load, as long as it's installed and enabled on your NIC. Then iPXE will initiate and take over. iPXE will bring you to the iPXE menu that we created, where you can select Install Windows 10. You should see a loading percentage while WinBoot fetches the files, and when all the files are fetched, you will be booted into WinPE, a screen with a command prompt. From there, the install.bat file will automatically run and assign drive letter Z to the SMB share, and then enter our credentials to log into the SMB share, and finally execute setup.exe that starts the Windows 10 install on the client machine.